Welcome to this series of videos in which we will look at end-to-end data pipeline that lands data in Apache Iceberg. Then we will query that data from Presto, use it from Superset dashboards, and show how we can query it from external tools. The data pipelines will be written in Spark streaming as well as Python. The data pipelines will be controlled via Airflow, and the data storage is provided by data fabric, Ezmeral data fabric, both as S3 and the Kafka element is provided from data fabric. So all of this sort of integrates the entire portfolio. So we will start looking at it now. So what you see on screen is our data fabric, our Ezmeral unified analytics, and this is our landing page. So we are looking at when we log in, we will end up on this page. So this is our Kubernetes driven compute platform. This is where we will run all our data pipelines as well as our Presto and Superset. So before we go any further, I would want to show you the data layer, which is the Ezmeral data fabric. So you can see that this is the Ezmeral data fabric landing page. This is the control center. And Ezmeral data fabric is a single unified cluster. So you can see that it has streaming, it has standard file storage, it has NoSQL tables, it has streaming, as well as it has object store. So the Iceberg tables that we will store are within the object store of Ezmeral data fabric. So we will go and take a look at that object store component. So when we click on it, we land into an object store interface, and this becomes our storage for our demo. So if we look at the buckets, you will see that there are a number of buckets, but the most important bucket is this, the Iceberg data bucket. And within this bucket, if I look at the various prefixes, you can see that I do have a warehouse prefix, and this is where all my tables will be organized for Iceberg. So if I go under this, you will see that I do have two different schemas. The one that we will use will be the default schema. Now all of this data structure automatically gets created from SQL commands that you are issuing. So I have already ran some commands. That's why you see all of this structure here. So when I go into my schema, default schema, you can see that I do have a table that I call Kafka ingest 5, and as with all Iceberg tables, it has a data element, and you can see that it has saved a bunch of Parquet files as data files, and then it also has a metadata element, right? So this is where all the manifest files, manifest lists, as well as the snapshots are all stored, right? So this is the metadata layer that Iceberg maintains, which gives it such a flexibility. So going back to our unified analytics, which is our compute layer, Kubernetes containerized compute layer. So let's go into the notebook portion of it, and let's just look at the code first. So we have a few notebook servers. So this is the integrated development environment for any developer. So this is how you can create code and look at code. So let's just look at the code that we are going to run. So let's just give it a moment to load. Yeah, so when it loads, we will see that we have code for the jobs that we are going to run. So what you see here is two components. So one is the Spark streaming consumer that will run on Spark on Kubernetes, and then there is a Python oriented producer. So first let's look at consumer. So it's a the consumer is creating a Spark session, and you can see that in the Spark session I'm pointing to the S3 location for my table. So basically this is the warehouse property within Spark. So all the tables etc. will be determined based on the SQL commands that you issue. But this is the warehouse where it is all stored, and then you can see that your Spark SQL will allow you to sort of access now this as a catalog.schema.table, right? And you can continue to create tables, append data to them, change schema, and so on and so forth. So what you see below, going below is we are basically creating a schema for the messages in Kafka, and then we are defining some connection properties for that stream, right? So I'm just showing the streams portion of it on the Ezmeral data fabric. So this is we are using a Apache Kafka um, um, brokers. So you can see that one for that stream there are some parameters that we can specify. So of course we have disabled the authentication, but the authentication can be added. It can be as simple as a password but as rigid as a SSL certificate. So it can be quite secure, but given that this is a demo, we are essentially just using a simple uh, Kafka broker, right? And a Kafka topic. So that's what you see here. Then when we look at the subsequent code, what we are doing is basically we are just looking at reading the stream as a structured data frame. So we are just cleaning up a little bit of the schema, and then all we are doing is just creating a write stream, and then the format is Iceberg, and that's how it knows how to write the stream, and this will continue forever. So there's really not much benefit in running this under Airflow, because once you launch it, the job is going to run continuously, but nonetheless we will later launch it via Airflow just for sake of simplicity of management, right? So that's where all the data goes, as I mentioned. So now maybe it's a good time to switch to the Python part of it. So one additional element I want to mention is that there's this table that I'm mentioning here, warehouse as well as table, and then I'm also mentioning a checkpoint location. So that is also a separate bucket where Spark maintains the checkpoint. So the Spark knows exactly what data is already ingested and what net new data needs to be ingested. So when we switch to the Python portion, so we are using a Kafka Python library to connect, and what we are going to do is we are going to generate some fake data. So in practice, your data producer could be your IoT data, could be your change data capture tool that's generating this data. This could be coming from operational systems. It can come from a variety of locations, right? But we are just simulating that into this producer. So you can see that we are generating a very realistic looking record, and each time we end up generating 100 records, right? So all of this data, realistic looking data that gets generated, and the good part of this is that we can look at specific IDs and specific client names, and then make sure that those are actually indeed getting ingested into the Iceberg. and we can also check those via queries from Presto, which will connect to that iceberg table, right? So this just gives us a good way to validate. So now let's just go and switch to airflow. So this is where the airflow will launch. So again, this is an airflow running as part of Ezmeral unified analytics. It's again airflow running on Kubernetes, and you can see that we have created a few DAGs here. So there's a one Kafka Python producer DAG, and then there is a Spark consumer, right? Now, as I mentioned, when we launch the Spark consumer, it will run continuously. But nonetheless, with Airflow, it is a easy way to look at all your data engineering pipelines in one place and manage them from one place. So that's great from a ease of administration perspective. So when I look at it, I have already ran it. You can see that on one instance I did run it for quite a long time. So this is the end of my part 1. We will resume further in part 2. So thank you.